Okay, first thing that we discuss within the last part of lectures, we look at how we can store data in different ways, in different what we call data structures. Under the Python programming, and we learn four such data structures. We start with lists, tuples, and sets and dictionaries. And we discuss sets. So there are different properties that you need to understand in these different data structures. Starting from list, and I told you it's an organized or ordered set of items, and you can manipulate. And when you take tuple, it's like a read-only list, which means you can create, but then you cannot modify it. When it comes to sets, you don't have an order. We call unordered collection of unique items. Okay, so the example that we have discussed is we are going to have a collection of numbers. So the first thing that you need to notice is the curly brackets. And within the curly brackets, you can have a set of numbers. And then remember how Python stores is random. So it will not preserve this order. So printing them, which will be very similar to previous two cases. So in this particular case, it will print the whole set. And with the for loop, we can print each item. Getting the length will be also the similar to the previous one. We can use len method. If you want to add, there are two ways that you can do. One is you can use add, and within bracket, you can have a single item. In our case, it's just a number. Or you can use update method, where you can provide multiple items as a list. So you can notice here, we are adding 3 items to the set as a list. And you will also notice if you have multiple items or the same items. So since it's a unique set of numbers, it'll create a unique set. Removing, also we discussed, there are two techniques. First one, you can use remove method. Problem with the remove method is if number is there, you don't have a problem. But if you don't have a problem, then it will break the program. So you will get an error. So which might be problematic in some cases. Therefore, there's another method which we call discard. In discard, so you will notice that there will be no error in this particular case. Then you will have deletion. Again, remember, you can remove the set using just del, right? Individual items, you will have these two techniques. But if you want to remove the whole set, then you can just use del. Okay, so let's start with the remaining ones. So the first thing we discussed today is called dictionary. Now, if you remember what we discussed with list, we have set of numbers, right? So let me take let me change the sharing. Can you see my Python window? Okay, you can see now. Right. So the first thing I want to discuss is, as a list, we use, set of numbers. Let's say 4, 6, 2, 4, like this. Now remember, when you want to access, you use numerical index. So for example, 0 will give you the number 4. If you need the second value, you can have numerical index 1. The problem with this is, when you have very large set of numbers, for example, you don't know like which one you are going to accessing, from the location. But sometimes we want to pick a particular item, then you have a difficulty to remember. So therefore, we typically use dictionaries. And dictionaries, we can use a special value instead of a number, just 0, which we call a key. So therefore, in dictionary, we have two pairs. We have key and a value. Key is to access, like in this case, we are using a numerical index. So we can use anything we want, right? So that's normally the idea of using dictionaries. Right. For example, in our example, we use, as an example, we use keys in English and values in Japanese, like a dictionary where you search for an item using a word, right? So in this particular case, we will say those are the keys. So therefore, in this particular case, 1, 2, 3, they are keys, and equivalent values are in Japanese. So ichi is for number 1, ni for number 2, san for number 3, and so on. So when you're defining, you can say, okay, number dictionary. You can use any, name. And we use curly brackets. Actually, we are typing as a 2 in several lines, but you can type it in a single line if you want. But only thing you need to remember is we have to have a key and a value pair. Right, you can comma separate each key and value pair. Right? So once you create it, you can use as earlier, for example, if you say print number dictionary, so you will notice that you will have all key value pairs. So as I told you earlier, instead of just using a numerical index in list, we can use these keys, or we can say, okay, number dict. For example, I can say 1 to access the value in under the key 1. So it's ichi. So this is useful in many cases, like, for example, those who are going to work in data. So if you have a set of data, and let's say you want to access a particular column in a data set, right? You don't know which column you need to access, but it's easy if you know the name of the column. For example, let's say I'm going to store your data as a student, and I might have like multiple columns, like your registration numbers, your names, addresses, and so on. So if I want to access, let's say, address column, I can just say the name of the dictionary and then address, for example. So which is very easy. And this is the idea we use in, you know, smart data structures, like in pandas, right? In pandas data frames, we are using actually dictionaries where you can access values. Okay, coming back to the printing. there are a couple of ways that you can print. Your dictionary, you print as it is with just print and then the dictionary name. But then again, if you use a traditional way of printing individual items, you have to keep in mind, if you use what we use with other data structures, like for I in the dictionary name and printing I, this will print only keys. You will get 1, 2, 3. So if you need values only, then you have to use values. You can have number dict dot values. But then if you need the pairs, that means both keys and values, you have to use number dict dot items. Right. At the same time, getting a length is just len, and accessing individual items, I actually explained to you, you can just use this. But then again, if you want to add new items, adding a new item is same as first, accessing, but you have only 3 values right now, 1, 2, 3. If you want to create a new one, you can just use the same technique as accessing them, and you can say 4. And we don't have 4, so we can provide a value for this. So if you use this, so this means that you are creating another item in the dictionary, so which is 4 yon, right? Okay. So in that particular case, if I taught this to you, then I can move on. And in this particular case, changing will be the same. And then you can delete them. Okay. So these are the basically the methods that we will use. Then use of strings. Okay, now so far we use functions or methods as a way of organizing our programs. But there's a different paradigm, we say, the different way that actually we can work with all of these. Because the problem with just use functions or methods, we are not going to have everything in a one single place. So initially we use that structured way of programming. So that's what we have learned early. So object orientation is slightly different idea, where we can keep all our data as well as methods in a single place, like a container, which we call classes. Okay, so OOP is, we use what we call classes and we call objects. Class like a template we use, where we can have data, we call instance variable, and functions we call methods. So what happens in OOP is we can use idea of a class that defines the structure of data and methods that you want to use. And then you can create individual instances. Now, for example, now let's say I want to represent you in a program. So in that particular case, if I'm using object orientation, I will create a class for you. And I will list, okay, so the name of the class will be, let's say, students. And all our variable, we call instance variable, will be whatever the data I want to store about you. So like your name, your registration number, right, your contact details, and so on. And then the methods is what I want to do with you, what things that you do. Like, for example, you can study, you can, sit for the exam and so on, right? So in this example, you will see we are representing a credit card. So the class name is credit card, and these are the variables. and these are the methods. So usually you have three parts. So we can actually use diagrams to represent these. So in object orientation, we can create class for different entities. Like for example, in a university environment, we can create classes for students. We can create a class for lecturers, and we can create class for courses, and we can represent their relationships, right? So you will learn more about these things if you learn more in computing. Right, coming back to this, you can notice that we can represent various entities like a person. We can list what things we want to store and what actions we need to perform, right? And then similar to that, if you think email, you can see we can have recipient list, subjects and the body. And the methods would be like how we can add an attachment or a file and how to send it. A car, we can use data that we need to store about the years and the models and the mileage of a car. And we can define methods like accelerate and brake. So you can notice that, so this can be applied in anything that you want to represent. So you will have a single container, which we call a class, right? So defining class we discuss, and then we have to create, individual objects, we call it. Like it's like a student class. And if I want to represent each and every one of you, I have to create what we call the objects. So in objects, we keep the values for each of these variables we have defined, right? So in this particular case, creating objects from classes, we use a constructor. So constructor will actually create this particular object. So that's what happened in the process, right? Now, as we can discuss, this is very useful. How we can define a class will represent what data we need to keep in a class, and we can use a set of functions or methods, how we can handle those data with these methods, right? And sometimes we will also call attribute for this data that we are going to have, right? Different, names we use. Right. Now, very important thing that we need to understand is when you are creating objects, and sometimes we are going to interact with other objects. So therefore, let's say, if I want to represent like two students, right? So we can interact two students, we can have two objects. But there's a place where you can talk about yourself at that particular, object. So the self can be used to say that you are going to talk about your own variables, whereas we can talk about the other variables, right? So therefore, self keyword, which will also use within the class definition to say that you are going to work with your own variables or your own methods. So let me explain this. So here is, we have a simple class we call student, and we have one data or one attribute, which we call name, and we have two methods, right? So class definition starts as class student, and then we can have some string for us to use when we get a help to know what this class about. This place is very important. So in this place, where we normally call constructions of this class. So during the construction, we can assign a name. So that means when you want to create a student object, we have to provide a student name. That student name will store within the name. So you can notice self keyword here. which represent that you discuss about your own variables. Self is for that, right? So now this is the class template, and you will notice when you want to create a student object, right? The technique is you have a variable and then your class name, and then whatever the things that you need to create the class. In this particular case, we are expecting a student name. So we provide a student name, Saman, here. And that Saman is assigned to the variable name, right? Okay, then the methods. You can use any methods you want. For example, here we have a method to get the value of the name. So get name, self means you work with yourself or your the same object, and you are simply returning a name. So what happens if I say s1 dot get name, sorry, get name, and if you put the bracket, it will provide you whatever the value we store under variable name. And using other methods is easy. You just use the object dot and any methods that you want. Right. So let me quickly demonstrate this one. So in my case, we use class student. I will use minimum. So def. Remember that you are using 2 underscores. These are like special case. So I made a mistake. Okay, I forgot the brackets and whatever the values that I want to use. So I'll start from the beginning. So I will use class student, and this is def underscore underscore init underscore underscore. And then you will use self keyword, and then whatever the name that you want to have it. So I will say student name. Right. Within the body of this, we will define our the variable, which is name, we call self.name, and then whatever the values we receive from the outside. Right. So this will be defined in this. Then def get name, and we just say self just to say that you are going to this, and we are returning self.name. I know this might be a bit strange or bit you are not uses, but then this is very common method that we will use. Then the second one is we use study. Right. This is actually minimal class. So when I want to create S1, I will use student, and I said someone. Right. And as I told you, if you want to access whatever the variables, you can say s1.name, which you will get someone. But usually this is not recommended. You use some methods to access whatever the data. So the ideal way is you can use s1.getName. So sometimes in some programming languages, we say getters and setters to access what is available. So getName is the proper way of accessing data within the class. s1.study, which will return, study. Okay, so this is the simple idea. Actually, this is a bit complex, but we represent, we introduce this in as your beginner course, because many of the places you have noticed that in Python, everything represented classes. So you should know like what is inside in a class, right? And the self keyword, normally you will also see, for example, let me say help list, right? Um, and if you say help list, you will get a lot of information about list, and we know it's a class. So if you go to any of these methods, and you will notice that self keyword is used there, because in Python, everything is represented as classes. So you should have the basic understanding how you create class and what self is. And I told you like self will access its own variables and the methods, right? So when you want to access your own variables, we can use self dot whatever the variable name, right? So you can notice, let me use, for example, help list dot insert. So you will see this self is always here. But whenever you want to insert, you don't put any values here, because this will be representing whatever the values belongs to its own objects. Okay, so I hope you got the basic understanding. I have given you a full example of how to use a credit card. We discuss how to define various elements in a credit card. That means how to store customer name, bank account number, credit limit, and so on. And then, getting customer details. And then you will also notice that defining methods. So which basically manipulating these values that we got. For example, get, you can get any of these values within this. Getting a customer, we use get customer. Similar to that, you can get bank, get balance, and so on. Right. But when you want to make a purchase, you will notice that credit card used to make some purchases, right? So when you make a purchase, first of all, you have to check whether you have enough balance in your card. And if you have a balance, then you actually subtract and then you change the balance. Otherwise, you say false, because you can't make more than what you have in a credit class. And then you can make payments. When you make payments, you will notice that it will adjust the balance, right? So here are some cases that actually we discussed. We will store, create a one instance of the credit card object. And in this one, we can get their details. So first case, we make some purchase of 25,000. We set the credit limit 50,000. So there's no issue. You are trying to purchase a 30,000, but you know that you don't have 30,000. So which means that it will not change the balance, because you are actually exceeding the balance. But if you have less amount, then it will be deducted. And the third one is you make some payments. Right. Okay, the constructor that we use here, like the way I use, which is the way that we create objects. So in our credit card example, we use create an object called CC, right? And internally, you use underscore underscore init method. This is a special method with it, and that serves as a constructor, right? So those are the basic ideas that I want to discuss with classes. So some of you have since already done this in the lab classes, you might have a better understanding. The last part of our lectures, we introduce two modules in Python, which is very useful as an engineer. The two modules that we have discussed is NumPy and Matplotlib. With the time limit, I don't think I can cover Matplotlib, but it's basically a visualization module, which I think very easy. But since the NumPy is very important, I want to focus numerical Python. This is very similar to matrix manipulation software like MATLAB, which uses V earlier. So early days, we used to have these tools, but then again, they are proprietary and commercial. And then now the Python is very popular as a free and open source alternative for many cases. So NumPy libraries, the basic building block for many of the other libraries. So understanding NumPy is very, very important. So therefore, I'm going to discuss the basic ideas that you need to understand under NumPy. So we know that many of the cases, the idea of representing as matrix is very, very important idea. So you know that when you have rows or columns, they are vectors. But when you have both rows and columns, we define them as matrices. So many of the things you see outside can be represented as matrices. For example, a data set can be represented as a matrix. An image we can represent as a matrix. So therefore, this metric representation is very, very important as engineers, because we are going to work with data most of the time, right? So therefore, in numerical Python, how they define it, they call it as n-dimensional arrays. We normally call ND arrays. So if you compare what we already know, for example, with a list and how we represent as NumPy arrays, you looks the similar. But in reality, if you go for more complex or very large representations, NumPy is very efficient. So that's why we have to switch from lists to NumPy arrays, right? So in this example, you will notice that in first case, we represent 1, 2, 3 as a list. And if you check type, it will tell you it's a class list. But if you represent it as a NumPy array, first of all, you have to import it. And we say import NumPy as NP. This is shortening. And we have a special method that you have to use, np.array method. And then you can represent anything as a list, right? And if you look at the type now, it represents as a NumPy ND array. So important thing is, so you already know that list has its own set of methods. Similar to that, NumPy also have various methods where you can efficiently work with lists and matrices. So that's why most of the time when we want to represent vectors and arrays, I recommend you to use NumPy. So I think you got an you understand why we need to represent anything as NumPy arrays. Okay, right. The second one is we have to learn how we can represent things. The first thing we discuss is how to represent anything as vectors. So when we say vectors, there are two types. We have row vectors and we have column vectors. And in this example, you will notice that how we can represent everything as a row vector, right? So if I go with this, we can notice, let's take this. We have to first say import NumPy as NP. And then we can say, okay, whatever the array, np.array. And then we can say 1, 2, 4, and 5. And you can say print A, which will print. And you don't see any difference. It looks like an array, but it's how we represent inside the computer is slightly different. It'll more efficient. So therefore, although you don't see visually, there's a difference, but actually there's a difference of when you work with very large arrays and matrices. So therefore, very important that you use this. And if you use type A, you will also notice that it's NumPy ND array. So when you actually using this is perfectly all right. You can use our traditional way. But many recommend uses of Google Colab. So therefore, you can use the traditional way we have discussed here. But then I recommend you switch to Google Colab because it's the state of art, the way of people work with data. So since from this point onwards, I would like you to get familiar with Google Colab. So if you go to colab.research.google.com, and let me share. So you can notice that many of the time I'm actually using a lot of notebooks, doing simple Python programming to natural language processing, even doing some experiments in AI. So everything can possible, and use of notebooks is highly recommend. You can work with as a team, right? So therefore, getting used to this notebook environment is very, very important. So in notebook environment, we will have like two parts. You can have codes and you have texts. I hope you are familiar with both, but I will just use code. For example, the same thing if I type here, and now with the AI, you will also have code completion, which is very useful feature. So common tasks can be done without any effort, right? So in my example, we have 1, 2, 4, and 5. And then we say print A. And if you say run, you will get directly the answer. So use of the notebook environment, therefore, is highly recommended and useful. So I forgot to import. Right. So this is interesting, and you can download this, and you will get my note as a PDF, which is very easy. You can download it directly, in different formats, right? And this is now the state of art of working with data, right? So I hope you are already familiar with this. So let me go back to some of the important parts in NumPy. Right. So column vector, on the other hand, you have to represent each row separately. So you can notice that we are using each row separately as a list. So we have a list of list representation. So in NumPy, we can use shape and size. This shape will give you number of rows and the columns. So here we have 4 and 1, which represent a column vector. One of the important things, if you compare the list don't show you this as a column vector. I hope you remember. Whereas in NumPy, you can notice this as a column vector, right? So it's printed as exactly what we want. So it's easier for us to work with data. The size will give you how many elements you have inside. So which is 4 in this particular case. Right. A range is very similar to use of range function, but this will create arrays. Again, you have 3 values. We have start, stop, step. So if you want to create an array with numbers from 1 to 10, we can use a range, and start will be 1 and end will be 11. So I hope this is very familiar to you, which will create a vector, a row vector, which consists of numbers from 1 to 10. For example, if you need odd vector, then we specify starting value as 1, end is 11, and the step is 2. So which represent odd numbers from 1 to 10, right? So you can use this. Very important, for example, when you want to draw graphs, so we can actually use this technique to generate values. Right. So that's about a range method. Then there's another method that you can use, which we are not learned in previously. We call linspace, or we call linearly spaced values. Now in linear space values or linspace, we provide only start and end values. If you just use start and end values, so remember in this particular case, both values are included. Both values are included. So if you look at the generated vector, you can see 1 and 100. So what happens here, it will generate exactly 50 elements. If you look at the shape, you see 50 here, which means it will generate 50 equally spaced elements between 1 and 100. So between 1 and 100, you have 50 elements here. Right. So if you want to need, let's say, 100 elements, you put it as a third argument. So for example, in this particular case, we say 1, 100, 100. So which means this is to say that, okay, between 1 and 100, I need 100 elements. So you need that, okay, you have values between 1 and 100. But make a notice that you have a dot here, which means whatever the values we generate with this function, we get them as floating point numbers. So if you need integer values, you have to put it as D type, data type. Let me see. You have to say D type int. Okay, let me show you that. Right. Okay, maybe, yep. I'll go to this. I take another code window. So we can say y equals np.lin space 1, 100, 100, right? And let's say print y. Yes, you will get exactly 100, but you notice that it's floating point numbers. But let's say you need it as integer values dot linspace 1 comma 100 comma 100 comma d type we call int, and we say print y. So by doing so, you can get, right, integer values. So important thing here, this is fine, but if you need, let's say, integer values, you can include this part so that it will convert the floating point numbers into integer values. Right. Defining matrices, we have already discussed on the list. You have provided as a list of lists. And same method that we have discussed with the list you can use. So here we will say, we will print, and then you will see it as a matrix form, which was not possible with the matrices. And then you can also notice that here we have a shape. And then which will give you, this is 3 by 3 matrix. And you can access 1 comma 1. Now, one thing I want to highlight is use of this. You can directly use comma as well when you want to access. Right, generation of matrices, you might have already done it, but just for your information, there are methods that we can actually generate matrices. So this is very, very important for you when you want to create different matrices. If you want to fill a matrix filled with zeros, you can use this method. If you want to create a matrix filled with ones, you can use ones method. Okay, interesting ones. If you want to create diagonal matrix, which you have ones along the diagonal, we can use identity matrix, we call it. We use I. But then again, defining or generating random values is very, very interesting. So we have two methods here. There are many methods actually. So random.rand will generate random values, and randint we can generate random integer values. So you can notice that there are many methods which will support generation of matrices in NumPy. Okay, some examples, use of ones. You can notice that you use first one as a row vector and the second one as a column vector where we will convert it into values. Then identity matrix, you define, since it is symmetric, you define what you need, what you have, right? So 3 by 3, we put 3 here. If you use 4, it will be 4 by 4. But then again, if you need like particularly like the dimensions, we can use it as a tuple. So in this one, it says you need 2 by 3. Okay, somebody's raising your hand, like any question? 392. Okay, right. I think time's up for the today's session. And I will provide you all the information you need. In this particular case, we need to cover up to numerical Python and Matplotlib, which you have already had the lab classes.